these are two triangles that if you don't know them, memorize them. Memorize them, because we will be using these triangles for probably the next month, at least a month or month and a half. So, a right angle. Does anybody come up with a good number? Danny, what'd you come up? 2. Good. And 1. Perfect. Perfect. Memorize this. Now, the formula is just like this. 1 is S for 1S. 2, I'm taking S and multiplying it by 2. And in this case, I'm taking S and I'm multiplying it by radical 3. Both of your triangles, this is an easy way to remember them. Both of your special triangles have one radical in them, right? One radical. Could I possibly have radical 1? No, because radical 1 is 1. So that could not be a radical. Well, a radical 1. That 1 could not. Notice that they add up to 3. 1, 2, God bless you. 1, 2, 3. Could my third side, could this, if it was a 3, could that be a 3 in this case? Could this side be a 3? Why not? It wouldn't meet because it's bigger than the hypotenuse, right? Could that side be bigger than the hypotenuse? The hypotenuse has to be the largest side. Radical 3 is approximately like 1.732, somewhere around there. So, memorize this. 1 is the smallest. Opposite the smallest angle is 1. Opposite the biggest angle, double it. Add these two together. 3. This cannot be 3. There's your radical. Find a way to memorize this. From this, you can transform it to anything you want. You guys remember your unit circle? Okay. A unit circle is just that, 1 unit. A radius is 1 unit. So therefore, this guy right here, this hypotenuse would act like your radius has to be 1. So if I want this to be 1, and if you want to write it on the small triangle down here, I can't move my thing, I'm just going to use that triangle. If I want this to be 1, what do I divide 2 by to be 1? 2. So if I divide that by 2, I have to divide everybody by 2. So then I get 1, radical 3 over 2, and 1/2. There's your unit circle. You could write it like on the third one, because I think that's a small one, isn't it? Or the last one, maybe. Maybe the last one. This is your unit circle, where the radius is 1 unit. Because when we talk about your unit circle opens up like this. When the angles terminate, that's where it drops the triangle. So there's your hypotenuse. That's what we call 1 unit. Make sense? So if you forget your unit circle, go back to the one you know and love, and make this into a 1. Now, sometimes this will be 6. And I say, label the rest of your triangle. So match it up to your formula.
You want us to write these down on our triangle?
Yeah. I'm sorry, I skipped to the unit circle only because that's the one where it's divided, so I kind of wanted to show that one to you. If this was a 6, can you label the rest of this triangle now? So put the ones you know. Put the ones the way you know. You know this is 1, 2, radical 3. So now, from 2 to 6, what did I multiply by? 3. So multiply this guy by 3. Multiply this guy by 3. What do we call these? What do we call these triangles? When they're not congruent. Similar. And their sides are in proportion, right? Their sides are in proportion. For all our triangles, the angles are not changing. The sides are in proportion. Okay? So now, what happens if I don't know why. So what happens if this? Good. You want this guy to be 1, right? Your favorite triangle is 1, 2, radical 3. Normally there's only one radical. If this guy's a radical, then which one is not going to be a radical? Well, maybe not. In this case it probably will, but I'm going to multiply everybody by a radical because I want this to be 1. Or divide by a radical. I want this to be 1. So what am I going to divide by? Divide everybody by radical 5. This has to be a 1.
Oh, I thought you would multiply it.
Okay, if you want to multiply it, you can multiply it.
Right now? Like, wouldn't you just multiply, like, the 2 by radical 4?
Well, if you want this side to be a 1, if you want to go back to what you know and love, and you want this to be a 1, I would have to divide by radical 5. So I would have to take my original ones and divide everybody by radical 5. Isn't that right?
The other one, that would be the, you would have to divide, like,
Oh, no, wait, hang on.
it wouldn't be 2 on that side if it's...
All right, so let's not make this a 1 yet. You're right, let's not make this a 1. I don't think I could erase. I'll just move it out here. I don't know why my board doesn't erase. I just have to move them away. I just throw them away. I can't understand why this doesn't erase. Even if I put the erase thing, it doesn't erase. So there's a couple of ways you could do this. You want to multiply this by radical 5?
No. Just multiply, like, the other... I thought we were just trying to find out what the other 2 sides are. That side. Because, like,
I do. I want the other 2 sides, but did you say multiply by radical 5?
not that one, because that's what you multiply the 1 together.
All right, so how do I get this one?
2 times radical
2. Why did you multiply it by 2? Because this is 1, 2, radical 3. So multiply this guy by 2. It's just twice this. If it helps, do this. Once you get your 1, 2, radical 3, put your s's here. Put your sides there, your formula. And then it makes a little bit more sense. So when I get down here, I have to multiply my side, which is what? Radical 5 by radical 3. What is radical 5 times radical 3? Radical 15. So you can give me a similar triangle for any side that we set you up with. Most of the time, we won't have to worry about this. Most of the time, we'll either be using the 1, 2, radical 3, or the unit circle. So again, the unit circle is the most important one that I want you to get. This little guy down here. When it's on the unit circle, this guy is a 1. So if this used to be a 2, and this used to be 1, and this used to be a radical 3. How did I get from 2 to 1? I divided everybody by 2. So now I'm going to divide this guy by 2, this guy by 2. This is my unit circle. A unit circle is unique because in a minute when we make the chart, if you work off of your unit circle, your x is your cosine, your y is your sine. You don't have to divide anything out. You don't have to do opposite over hypotenuse because it's already there. Because when we put a hypotenuse of 1, divide by 1, you don't have to do that. So we tend to use the unit circle values if you're not comfortable with the unit circle values? Do your 1, 2, radical 3. It works out the exact same. So if this was my unit circle, 1, 1/2, radical 3 over 2, and this was my one that I like better. For instance, if I did the sine of 30 on this guy, what is the sine of 30? One over 2. Everybody remember this? So if I did the sine of 30 here, using these values, 1/2 over 1, which I don't really need my 1, right? So it's automatically the sine. So that's not going to change. You're just taking ratios. And if I went back and did the other ratios, they would all reduce to 1/2. This, you still have to know this. Anybody not know this? Did you guys learn this? Okay. For like a long time now? Okay. All right. When we get to the circle, I'm going to change it on you just a little bit, but I need you to know it for now. Okay. 45-45 triangle is just a little bit easier. What do we know about the legs of this triangle? They're equal. So what kind of right triangle do we call this? Isosceles. Good. Isosceles. Did you guys learn cofunctions? Cofunctions with the 30-60s? Well, cofunctions like the sine of 30 is equal to the cosine of 60.
Oh, yeah.
Did you learn those? Okay. So you didn't retain it? That's okay. We'll visit it again. Sometimes when you see it a second time, it starts to bring back all that old memory and builds that. This is nice because they're both the same. So anybody label this?
Yes.
Really? Hypotenuse is 1. Already gave us a unit circle. Now, you could also label it like this. Both of the sides are the same, right? Make them 1. So 1 plus 1 is 2. So doesn't one of these need to have a radical?
Yes.
So could it be the 1? Because radical 1 is 1. This is your radical 2. Simple way to remember it.
That's fine.
Side, side, side radical 2. So what we really did was say that if I want to put this on a unit circle and I want this side to be a 1, I have to divide this by radical 2. Therefore, I have to divide this by radical 2. Therefore, I have to divide this by radical 2. It should rationalize. Radical 2 over 2. The nice part about precalch, you do not have to rationalize. You can leave it 1 over radical 2. If you put 2 over radical 2, absolutely fine. Because we're so used to rationalizing that you just might automatically say that to yourself. But you can leave this just as it is. God bless you. So the 45 has a special case here. Okay. If I made this side be 10, what's this like? 10. What's the hypotenuse? 10 radical 2. Side radical 2. Remember, side, side, side radical 2. In trig, we work all our functions as exact values. We use all our radicals. We don't put them in our caps unless we're working something else out, like an application or something. But we leave everything in reduced radicals. Reduced radicals, reduced fractions. The reason we leave them in fractions because trigs are ratios. Ratios are something to something. So it gives us a fraction. good with this? You okay with your special? The 45 is a nice one. Let me go to the next one. Together. All right. Tomorrow we're going to talk radians. I'm going to show you how to convert to radians without using a formula. It's a pattern. There's patterns to your radians. So tomorrow we'll talk radians. Today we're going to talk degrees. Okay. Now, there's your basic angles. These are what we call quadrantal angles. See the word quadrant? What does quadrant mean? The four things, right? The four things. Quadrant. So it is. Quadrant angles. So the reason we say quadrant angles is this. Because in your circle, and this is going to be our unit circle, where the radius is 1, it's going to come out 1, 1, 0. It's going to go up 1, 0, 1. It's going to go out 1, negative 1, 0. It's going to go down 1, God bless you, 0, negative 1. We should be able to make this whole chart right off of our special right triangles and our quadrant angles. So we're going to start with 30, 60, 90. Now, if you want to start with your unit circle, that's fine. If you want to start with this guy first, so the one you love, this is fine. They all work the same. There's your unit circle. We divide everybody by 2 because we want this to be 1. So I'm going to divide everybody by 2. Either one of these is fine. So again, so sine of 30. Sine of 30 says the opposite over the hypotenuse. If you do this one, 1 over 2. If you do this one, the sine is the opposite because the hypotenuse is 1. So you don't have to divide by 1, right? So no matter what we make this, it will reduce down. If we did this, 2, what would the hypotenuse be? 4, what would this side be? 2 radical 3. So if I did the sine, opposite, over hypotenuse, 2 over 4 reduces to what? 1/2. They're similar triangles. They're in proportion. So it doesn't matter what triangle you come up with. You're still going to get the sine of 30. Okay? Cosine of 30. What's the cosine of 30? Adjacent over hypotenuse. Pick any of those triangles to do. If I pick this, the only thing I have to do here is reduce this. If I pick this over 1. If I pick this, radical 3 over 2. If I see where that came from? Adjacent over hypotenuse. You guys do with SOHCAHTOA? Tangent. What is tangent? Opposite over adjacent. So this is my reference angle still. Opposite over adjacent. This tells me keep, change, flip. Out comes the 2's. If I like this one better, 1 over radical 3. Do I have to reduce that? And again, you can leave these unrationalized. You don't rationalize it because when we flip them over, when we take the reciprocals, then you have to like unrationalize them first, or you have to reduce them again. Now, here's an easy way to remember your reciprocal functions. Sine, cosine, tangent. What's the reciprocal of tangent? That's the easy one. Cotangent. So we take this guy and just reflip it. Reciprocate. So radical 3 over 1 is the same as radical 3. Okay? Now, these have different letters. A C and a T. So the sine to either be cosine or secant. It's got to have a different letter. So the sine has to be cosecant. They got to have different letters, just like tangent and cotangent. Sine, cosecant. Take the sine and flip it over. So it's 2 over 1. 2 okay with you? 2 over 1. Cosine is your secant. Take that one, flip it over. 2 over radical 3. Okay with you guys? Right? You don't have to rationalize. Leave them unrationalized. All right, now, 60. All we're doing is changing your frame of reference. This is now my opposite. This is now my adjacent. This is my opposite. This is my adjacent. I'm skipping 45 for me because I want to show you cofunctions when we do this. So 60. The sine of 60 would be what? Opposite over hypotenuse. So that would be what? Radical 3. What's the cosine of 60? No matter which one you use. 1/2. So this is what we mean by cofunctions. These two angles are complementary angles in a right triangle. They add up to 90. So if I take the sine of 30, it has to be equal to the opposite function of 60. See that? See their cofunctions? If I take excuse me, the cosine of 30, it has to be equal to the opposite angle's other function. That's why we say cofunction. So just so that you see that. Tangent. Give me the tangent of 60. What's the tangent? Opposite over adjacent. Radical 3. And then, again, just go and flip these guys over. Sine, who's hooked up with the cosecant? Which one? Sine, it has a different letter. Good. So we come here, 2, radical 3. Secant, 2. And cotangent, we good with those? Okay. Now, let's hit the quadrant angle. Quadrant says this. This is the x, this is the y. This is the x, this is the y. I want you to write this down. Hang on, we're almost done. On a unit circle, write this on this paper somewhere. On a unit circle, the cosine of theta, any angle, is its x value. Because we divide it over 1, the hypotenuse, which we don't have to. The cosine of any angle is its y value, because we would take the y over 1. We don't have to divide by 1. And the tangent is the y over x. So for instance, 90. Cosine, let's do the sine of 90. Sine of 90 is what, according to what I just wrote? Sine of 90 is which value? The y value, so that's 1. What's the cosine of 90? 0. So now, tangent is y over x. Oh, can we divide by 0? This is undefined. So tonight for homework, I want you to fill out the rest of the sheet. The quadrant angle should be okay. Use this information. And the 45, 45, pick any one you want and do that.
How did you know
Because I put this on a unit circle. A unit circle says the radius is 1. So on my graph paper, it goes out 1 unit. So that would be, that point would be 1, 0. It goes up 1 unit, 0, 1. It goes out 1 unit, negative 1, 0. And down 1 unit. Oh yes, you can.